Welcome to lesson 7.5, day 2. On day 1, we looked at how to graph parametric equations, and we also looked at how to write rectangular equations from parametric equations. If you recall, we took our x equals equation and solved it for t, and then plugged in that expression into the y equals equation. We did have to consider any restrictions on the original parametric equations, and then also the final equation as well, and record our restrictions on the domain. Today we're looking at doing the reverse, starting with rectangular, trying to build a parametric given a relationship between time and x. Our first one is probably the most basic that we could do. Using each parameter to write the parametric equation that can represent y equals x squared minus 4. Then graph the equation indicating the speed and orientation. The graphing part I'm going to skip in this video because we've done that. We did that in our first examples. You make a table of x and y, you plot your points for x and y, making sure to consider, what are your maximum values and rescale from there, what are your y-intercepts and rescale from there, and then you can graph it, and you can even see in your graphing calculator using the original rectangular equation that it's going to be the same graph. So I'm going to skip that part for this video just to save you time in the video as you get ready to start. I can go over it in class with you when we meet again if you need to see some of the graphing again. So here we have this function y equals x squared minus 4. We need this in terms of t. We already know x in terms of t, so normally I'd have to get x by itself, but I already have t equals x, which means x equals t. There's one of my equations right there. My other equation is going to be where I plug this in for x. Y equals t squared minus 4. So that's y equals t squared minus 4, and x equals t. So this table, if we were making a table and graphing, I'll do the table, but I'm going to skip the graphing part to save time. This would be very, very simple. We'd have t, we'd have x, which is dependent on t, although it's the exact value of t, which makes it super easy. And they didn't give me an interval, so I can pick some numbers. Usually it's assumed for real numbers. Both of these functions have a continuous domain and infinite domain. So I can put any numbers in. I'm going to put in, let me see what I can put in. Give me 1 second. So I could put in -2, -1, 0, 1, 2. Well, the x is easy. It's the same number. And then you just square it and subtract 4 to get your y column. Not that bad. It's going to give you the exact same graph as this in the graphing calculator. In our second problem, we have a different relationship between time and x. So they are giving us one of the parameters. So again, we're going back to the function y squared minus 4 because they didn't give us a different one. X squared minus 4. This one, before I had x in terms of t and I had to solve for t to plug it in. Now I have to solve for x to plug it in. So I'm going to subtract 1 and divide by 4. T minus 1 over 4 equals x. Well, there's my relationship for x. That's the equation I'm going to use. It is a linear equation. It's really t over 4 minus 1/4. You can use that if you want, if you're going to generate a table for t, x, and y. I'm not going to worry about the table right now so much as plugging this back in. So I have to plug that in for x. So that is t minus 1 over 4 squared. Well, t minus 1 squared is t minus 1 times t minus 1, which is t squared minus 2t plus 1. And 4 squared is 16. I do need to separate these because I have a fraction, but I have a bunch of pieces up here that can be separated. So that's t squared over 16 minus 2t over 16. That will reduce to minus t over 8 plus 1/16 so I have plus 1/16, and I'm taking 4 away from it. 4 in terms of sixteenths, I'd have to multiply 4 by 16. 4 times 16 is 64, so 4 is really 64/16. So this will be plus 65/16. There's my function. There's my equation for y. If I'm making a table of t, x, and y, my relationship for x is this. X equals t minus 1 over 4. My relationship between y and t is t squared over 16 minus t over 8 plus 65 over 16. These two are my parametric equations. X is dependent on t, y is dependent on t. Give me some values of t, or I plug them in, like -4 to +4. Because the graph keeps going, since they didn't give us an interval, we would draw an arrow on the end of it. And then I can find my x's and y's just like we did in example 1. Pause the video for a moment and try letter C. See if you can find the parametric equations, x based on t and y based on t, for this function. Again, using the equation y equals x squared minus 4. Welcome back. So here we have, if you did this correctly, you have t equals 1 minus x over 4. You had to solve for x first. So you subtracted 1. T minus 1 equals the opposite of x over 4. You multiplied everything by 4. So that gave you 4t minus 4 equals the opposite of x. Solving for x, we get x equals the opposite of 4t plus 4. There is one of our parametric equations. We need the other one. Well, it's coming from y equals x squared minus 4. Y equals x squared minus 4, but in that x squared we have negative 4t plus 4 in place of x. Well, when I square this, negative 4t plus 4 times negative 4t plus 4, that's going to give me positive 16t squared. Negative 16 and negative 16t gets me negative 32t, and 4 and 4 gets me 16. So that's what I get after I square it, and I'm supposed to subtract 4. So my y equals equation is y equals 16t squared minus 32t plus 12. Again, I could graph this. This is easily graphed in my graphing calculator. We know what it should look like. I could plug in values for negative 4, negative 2, 0, 2, 4, even 6, negative 6 if I want, into a table for t. Plug them into this as my y sub 1 and this as my y sub 2. It would give me ordered pairs that will resemble this rectangular graph. But it'll be on the terms of this relationship between t and x. So your assignment for this day 2 of 7.5 day 2 is to do page 469, problems 10 through 16 even, 26 to 31, and 69 to 75. 69 to 75 is odds only though. So we're going to work on that. That's what you're working on for day 2. Have a great day.